Is learning an art or science? Students say it's an art, whereas teachers say it's science. But both are human activities, so it's difficult to distinguish. But between man and machine, this seems to be different. How it's different? The art of learning or the science behind learning? Learning means the changes in the system that are adaptive in the sense that they enable the system to do the same task or tasks drawn from the same population more efficiently and more effectively next time. Types of learning. Knowledge is acquired through many ways, and some of them are simple storing of computed information or rote learning, learning through advice, learning from problem solving experience, and learning from examples. Rote learning. It is the simple storing of computed information. Caching has brought improvements in artificial intelligence program. Data caching is used to store computed values that are used regularly. The abilities of rote learning include organized storage of information and memorization. The only difficulty is retrieval of information. Learning through advice. A computer is a dumb terminal without a program is fed into it by the programmer. So the programmer is analogous to a teacher and the computer to a student. Even the execution of a program requires intervention of a compiler or an interpreter. So a computer can perform better by making use of the programmer as an advisor. The advisor helps out the computer only when it asks for the help. The computer stores the advice given by the programmer, and the next time the machine can execute directly. Learning through experience by problem solving. This involves learning by parameter adjustments, learning with macro operators, and learning by chunking. Learning by parameter adjustments. Many programs rely on an evaluation procedure that forms together information from several sources into a single summary statistic. Example, game playing and pattern classification. Creating such programs requires knowledge of a period that determines the weight to be attached to each feature being used. Correct weight can be found out by beginning with an initial correct setting and then let the program modify these settings based on its experience. Features that appear leading to the success have their weights decreased or dropped entirely. The important thing to be noted while doing this adjustment is that the coefficient of terms that predict the final outcome accurately should be increased while the coefficient of poor predicates should be decreased or dropped at each of the steps that led to the outcome. This phenomenon is also called as credit assignment. The disadvantage of this learning type is lack of exploitation of knowledge about the structure of the problem and faces the same problem as hill climbing. Learning with macro operators. The objective is to avoid expensive recomputations. We can achieve this through macro operators. Sequence of action that can be treated as a whole are called macro operators. They are like regular operators with slight difference that they perform sequence of action instead of just a single one. A macro operator's preconditions are initial conditions of the solved problem and post conditions to the goal last achieved. In simple terms, it is similar to rote learning. Learning by chunking. Chunking is similar to macro operation. The idea of chunking came from the psychological literature on memory and problem solving. SOAR is a system which exploits chunking. The advantages of chunking are generality and flexibility, whereas the disadvantages of chunking are speed and duplication. The best example that can be quoted is the movie production. Let us listen to the words of Stuart Russell in a mission simulation. what AI can do if it is used in an army. The future is in your hands. Use it wisely for the benefit of mankind.
We have something much bigger. Your kids probably have one of these, right? Not quite. Hell of a pilot? No. That skill is all AI. It's flying itself. Its processor can react 100 times faster than a human. The stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it does facial recognition. Inside here is 3 grams of shaped explosive. This is how it works. Did you see that? That little bang is enough to penetrate the skull and destroy the contents. That is an airstrike of surgical precision. It's one of a range of products. Trained as a team, they can penetrate buildings, cars, trains, evade people, bullets, pretty much any countermeasure. They cannot be stopped. Now, I said this was big. Why? Because we are thinking big. Watch. A $25 million order now buys this. Enough to kill half a city. The bad half. Nuclear is obsolete. Take out your entire enemy, virtually risk-free. Just characterize him, release the swarm, and rest easy.
This short film is more than just speculation. It shows the results of integrating and miniaturizing technologies that we already have. I'm Stuart Russell, a professor of computer science at Berkeley. I've worked in AI for more than 35 years. Its potential to benefit humanity is enormous, even in defense. But allowing machines to choose to kill humans will be devastating to our security and freedom. Thousands of my fellow researchers agree. We have an opportunity to prevent the future you just saw, but the window to act is closing fast.
I'm sorry, Dave. I'm afraid I can't do that.
Learning from examples or by induction. The idea of producing a classification program that can evolve its own definition is quite appealing. This task of constructing class definition is called concept learning or induction. The history of artificial intelligence. In 1872, Arthur Samuel Butler imagined machine consciousness in his novel Reborn. In 1950, Alan Turing predicts computers will imitate human thoughts by the year 2000. In 1951, a computer program is created which is capable of playing draughts. In 1956, computer scientist John McCarthy refers to artificial intelligence for the first time. In 1963, the book Computers and Thought shows the groundbreaking progress on AI. In 1968, Arthur Clarke releases 2001 Space Odyssey featuring the intelligent computer HAL. In 1970, Unimation increased competition in the industrial robotic market. In 1994, human-level spontaneous speech recognition. In 1996, IBM's Deep Blue defeated world chess champion Garry Kasparov. In 1999, Sony introduces Aibo robot pets marketed for entertainment purposes. In 2005, Honda introduced Asimo, the world's most functional robot. In 2011, virtual assistant Siri, Apple, now Google Cortana, Microsoft emerged. IBM, a question answering computer system, competes on Jeopardy and wins first prize. In 2014, Google brought out GoogleNet object classification at near human performance. In 2015, Google DeepMind achieved human parity in playing 29 Atari games by learning general control from video. In 2016, IBM Rose becomes the world's first AI attorney, landing a position at New York law firm. In 2017, will increased automation change the global world market? Wait and watch. In students' point of view, how to apply artificial intelligence in video streaming. The hints are: use algorithms for network traffic prediction and classification. That brings to the end of the session. Thank you.